The best images of Pluto we have ever seen. Astronomer Edward Barnard was training the Yerkes Observatory's Bruce photographic telescope on a portion of the sky constellation Taurus. He wasn't looking for planets, but that night in November 1909, he took a wide-field exposure for 1 hour and 19 minutes, surveying a region around the Halley's Comet. Then he stored the plate and recorded the data in his logbook. What happened, though, is that nearly 100 years later, astronomers at Yerkes looked again at Barnard's photographic plate from November 11, 1909, and another taken on August 21 of that year, and found what they believe are the earliest known pictures of Pluto, exposed 21 years before the planet was even discovered. Astronomers used a tool called Megastar Sky Atlas software that gives a precise position for Pluto at any given date in the past or future based on current orbital data. But overlaying the simulated megastar position on the 1909 photos, they found tiny dots nearly at the limit of what can be distinguished from a photographic grain of the old plates at the same position. Another team re-examined the 1909 plates and compared them to the modern Paloma Sky Survey photos of the same part of the sky. The results were slightly ambiguous, complicated by the fact that Palomar images show faint stars at nearly the same position as the claimed Pluto. But on the November 11 exposure, they seem to see a faint elongated image at the indicated position of Pluto, and they consider this identification fairly certain. Whether that was Pluto or not, a long time has passed since these photos were taken, and today we have CCDs instead of photographic plates that perform much better. This animation from NASA combines various observations of Pluto over the course of several decades. The first frame is a digital zoom-in on Pluto as it appeared upon its discovery by Clyde Tombaugh in 1930. The other images show various views of Pluto as seen by NASA's Hubble Space Telescope beginning in the 1990s and NASA's New Horizons spacecraft in 2015. The final sequence zooms into a close-up frame of Pluto released on July 15, 2005. New Horizons literally revolutionized our understanding of Pluto, and therefore our understanding of the solar system, the place in the universe we are living in. So what is Pluto, where is it found, and why is it a dwarf planet? Pluto is a frigid world, billions of kilometers from Earth, and 30 times less massive than the then smallest known planet, Mercury. But Pluto was not alone. It was found to have 5 satellites. The largest, Charon, was discovered in 1978. The smaller 4 were discovered using the Hubble Space Telescope in 2005, 2011, and 2012, and were officially named Nix and Hydra in early 2006, and Kerberos and Styx in 2013 by the International Astronomical Union. The International Astronomical Union was also responsible for the decision of Pluto not to be a planet. The final resolution, after a bunch of draft proposals, came out at the end of the Prague General Assembly held in 2006. The definition of a planet in the solar system would be as follows: a celestial body that A. is in orbit around the Sun, B. has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, nearly round in shape, and C. has cleared the neighborhood around its orbit. This final resolution means that Pluto cannot be classified as a planet because it doesn't fulfill the third criterion. Nowadays, Pluto is considered a dwarf planet. In 2006, people at NASA decided that they wanted to know more about Pluto, its shape, its atmosphere, and geology. So they designed a specific mission with the aim of exploring Pluto. It was called New Horizons, and in 2006, it was launched. The mission's goal was to get to Pluto as soon as possible, and this is also the reason why New Horizons was launched by means of an Atlas V rocket. The mission launched on January 19, 2006, and began its journey to Pluto. To reach Pluto, the mission designers decided to use Jupiter as a gravitational assist. Basically, New Horizon would have swung past Jupiter for a gravity boost to get on the right path for Pluto, with a desired velocity, thus saving fuel. So although the mission was primarily designed for Pluto, the first encounter New Horizons had was the one with Jupiter. This was a unique occasion to test the instruments and camera on board and to conduct the first scientific studies. For example, this is a mosaic of 3 New Horizon images of Jupiter's Little Red Spot, taken with the spacecraft's Long-Range Reconnaissance Imager, or LORRI for short, on February 26 from a range of 3.5 million kilometers. The image scale is 17 kilometers per pixel, and the area covered measures 33,000 kilometers from top to bottom, 2.5 times the diameter of Earth. The Little Red Spot, a smaller cousin of the famous Great Red Spot, formed in the past decade from the merger of 3 smaller Jovian storms and is now the second largest storm on Jupiter. About a year ago, its color, formerly white, changed to a reddish shade similar to the Great Red Spot, perhaps because it is now powerful enough to dredge up reddish material from deeper inside Jupiter. These are the most detailed images ever taken of the Little Red Spot since its formation. LORRI took the images as the sun was about to set on the Little Red Spot. The LORRI camera was designed to look at Pluto, where sunlight is much fainter than it is on Jupiter, so the images would have been overexposed if LORRI had looked at the storm when it was illuminated by the noonday sun. The dim evening illumination helped the LORRI camera obtain well-exposed images. The nice thing here is that the New Horizons team used predictions made by amateur astronomers in 2006, based on their observations of the motion of the Little Red Spot with a backyard telescope to help them accurately point LORRI at the storm. On the 15th of January in 2015, the spacecraft began its approach phase to Pluto, and as it was getting closer, the pictures were getting better. The image resolution was something amazing, and astronomers began to understand what a major revolution this mission was about to make. New Horizons conducted scientific studies of Pluto in the summer of 2015, culminating with Pluto's closest approach on July 14, 2015. However, it should be said that this mission was not simple at all. New Horizons' team experienced a software anomaly, and the probe went into a safe mode, preventing the spacecraft from performing scientific observations until engineers could resolve the problem. On July 5th, NASA announced that the problem was determined to be a timing flaw in a command sequence used to prepare the spacecraft for its flyby, and the spacecraft would resume scheduled science operations on July 7th. Thankfully, the science observations lost because of the anomaly were judged to have no impact on the mission's main objectives. Hey, if you're still here watching the video, it means you're in love with Pluto. We constantly strive to make videos that excite a curious person like you, so be sure to subscribe now and press the bell notification. So what did New Horizons find out about Pluto? Before New Horizons, we know that Pluto was small and we only had blurred pictures of it. After New Horizons, we knew Pluto had mountain ranges, ice plains, glaciers, and even an atmosphere. The mountains likely formed no more than 100 million years ago, mere youngsters relative to the 4.56 billion year age of the solar system, and may still be in the process of building. That suggests the close-up region, which covers less than 1% of the Pluto's surface, may still be geologically active today. But how do scientists know about the age of these mountains? Well, they look around and search for craters. Like the rest of Pluto, this region would presumably have been pummeled by space debris for billions of years and would have once been heavily cratered, unless recent activity had given the region a facelift, erasing those pockmarks. And indeed, we can't find a lot of craters around. Although methane and nitrogen ice covers much of the surface of Pluto, these materials are not strong enough to build the mountains. Instead, a stiffer material, most likely water ice, created the peaks. In fact, at Pluto's temperatures, water ice behaves more like rock. But the cutest thing New Horizons showed us is that Pluto has a thin, tenuous atmosphere. This atmosphere expands when it comes closer to the Sun and collapses as it moves farther away, similar to a comet. The main constituent is molecular nitrogen, though molecules of methane and carbon monoxide have also been detected. When Pluto is close to the Sun, its surface ices sublimate, changing directly from solid to gaseous, and rise to temporarily form a thin atmosphere. Pluto's low gravity is about 6% that of the Earth's, and therefore it causes the atmosphere to be much more extended in altitude than our planet's. This is a picture of Pluto's atmosphere when backlit by the Sun. The blue color is close to what a human eye would have seen and is caused by layers of haze in the atmosphere. If you think about it, This sight is similar to the one astronauts can see every day on the International Space Station, only they are looking at the atmosphere of the Earth. For example, here is a view of Pakistan and India. NASA decided to also look at Charon. Charon is one of Pluto's moons. Actually, it is the largest one, and it is literally dancing around Pluto. Well, not entirely. Pluto and this satellite orbit around their common center of mass, which given the small size of Pluto, is a point in the space between the two objects. Around the dancing couple are 4 small moons, called Styx, Nix, Kerberos and Hydra. All 4 small moons are less than 50 kilometers in their longest dimension. Each also has a lumpy shape, because unlike Pluto and Charon, they aren't big enough for gravity to squish them into a ball. From looking at Nix as a point of light with the Hubble Space Telescope and with the New Horizons on approach, we knew that Nix's brightness regularly changed over time, and therefore it was probably elongated. However, the first image on the left really surprised us because Nix appeared to be round, not elongated at all. But this was just because we were looking down the long axis. The following images would look more potato-ish, and also, scientists realized that seen from a different perspective, Nix presented a crater. Nix isn't very large, and there is a very fine line between an impact that will make a crater that big and one that will break Nix apart. So either Nix was very lucky in surviving that collision, or it's a fragment of an older moon that was somehow destroyed. As part of an extended mission, pending NASA's approval, the spacecraft is expected to head farther into the Kuiper Belt to examine another of the ancient icy mini-worlds in that vast region, at least 1 billion miles beyond Neptune's orbit. Anyway, once it studied Pluto and its system, New Horizons' mission was extended. The spacecraft continued its unparalleled voyage on New Year's 2019 with the exploration of Arrokoth, which the team had nicknamed Ultima Thule, 1 billion miles beyond Pluto and the farthest flyby ever conducted. But what is Arrokoth? Well, first of all, it is worth saying that the team didn't know about the existence of this object before New Horizons was launched. This object was located and selected for New Horizons to visit after Pluto. New Horizons was healthy and well after Pluto, and NASA's team decided to adjust its course so it could reach Arrokoth. New Horizons flew by Arrokoth on January 1, 2019, snapping images that showed a double-lobed object that looked like a partially flattened snowman. It's also very red, even redder than Pluto. The object's strangest shape, unlike any ever seen, was the biggest surprise of the flyby. Here's a picture of it. Arrokoth orbits in the Kuiper Belt, a region in the outer solar system that is full of icy and ancient objects. Because they are so far from the Sun, the Kuiper Belt objects have only been slightly heated since forming and are thought to be well preserved. Frozen samples of what the outer solar system was like after its birth more than 4.5 billion years ago. So probably, the two pieces of Arrokoth merged together when our solar system and the planets were forming. The merge could therefore give us insights into how fragments, dust and rocks get together and form planets. Thanks, New Horizons. Thanks for watching, everyone, and what do you think about this video? Let us know in the comments section below. Be sure to subscribe, and we'll see you next time on the channel.